All right, I think I'm live now. Can someone in the chat confirm if I'm live? Let me check through my phone as well. Hi, hello. All right, so everyone, how are you? Rezo says yes. Okay. Okay, so I had way too many issues while starting the stream, and that is the reason I haven't been able to stream in the last 2-3 contests. Okay, so how many questions were you able to solve? We'll be solving Codeforces around 852 today. I'll be solving A, B, C, and D. So couldn't even do one question, Brazil. Okay. Hopefully you are just starting up. That's okay. Even I couldn't solve any question in my first contest. So need not worry about it. So then we'll say solve 3. Okay. A was tough. Yes, I agree. A was tougher than I honestly found C very easy. Okay. But yeah, A was tougher than the usual questions. Okay. Alright, so let's wait for 1 more minute and then we'll start. Okay, I'll be solving problems A, B, C, and D today. And all the 4 problems are, I don't think there's any particular concept used in any of the problems. They are more or less like implementation problems only. Can you give a hint for C? You have to use a set, if that is, you could count as a hint. How to solve problem like A faster. Just keep practicing. That's it. Couldn't figure out problem B. Yeah, B is a trickier problem. There is one edge case that you need to see, and then only you will be able to solve problem B. Could not figure out problem B. Yeah. All right. So math forces. Yeah, I can agree to that. All right. So let's not waste any time and let's start with the stream. Okay. I hope everybody is able to see my screen. Let me just refresh it. I'll be solving problem A, B, C, and D. So let's start with the very first problem, which is yet another promotion. Okay, the famous store Second Food sells groceries only 2 days a month and the price in each of the days differ. You want to buy 10 kilos of potatoes for a month. You know that on the first day of one kilo of potato costs A coins and on the second day B coins. In Second Food you can buy any integer kilograms of potatoes. Fortunately, Second Food has announced a promotion for potatoes which is valid only on the first day of the month. For each m kilos of potatoes you buy, you get 1 kilo as a gift. In other words, you can get m plus 1 kilograms by paying for m kilograms. Okay. So basically, what is the problem trying to say? Let's see. So basically, there are 2 days. Okay. Day 1 and day 2. And on day 1, the price of potatoes is A per kg. And on day 2, it is B. Now, there is a scheme going on for day 1 that if you buy m potatoes, you get m plus 1 potatoes. So basically, 1 free potato. Okay, that is what we have in the problem. And we need to buy n number of potatoes, at least n number of potatoes. Okay, that's pretty much the entire problem. So for example, if we look at the very first problem, okay, so we have what? So here, let me just do one thing. Okay, so if you see, this is nothing but T, 5 and 4. So basically A is 5 and B is 4. Okay, what is 3? This 3 is nothing but N. So N is 3 and M is 1. So what this actually tells us, if you buy 1 potato, you get 1 more potato free at a rate of A. So basically, if you bought your first potato at A price, which is nothing but 5, you will get your second potato free. Okay, what are the total number of potatoes that you have to buy? You need to buy 3 potatoes. Okay, so what you can do is you can buy the first potato using A, second potato will be free, and then you can buy the third potato using B, which is 4. What is 5 plus 4? 9. That is the answer. If you see, 9 is the answer. Okay. Similarly, let's look at the second case as well. So in the second case, what do we have? We have A is 5, B is 4 again. Okay. N is 3, but M is 2. So basically, if you buy your first potato using A, second potato using A, okay, so this was what, 5, this was 5, your third potato will be free. Okay, and you have to buy 3 potatoes only. So sum of these is what? 10. What is one other way that you can use? You can do one thing. You can buy your first potato using B, second also using B, and third also using B. What is B? B is 4. So the total will be 12. Since this 10 is smaller, answer is 10. Okay, so let's look at the logic. So if you see, sorry. Okay, so what did we really have? We had 1A, okay, 1B, 1N, and 1M. Okay, what are the basic ways through which we can buy n number of potatoes? One way is you can actually buy all the potatoes using A only. So A times N. This is one probable answer. Okay. What is one other probable answer you can do is buy all the potatoes using B. That means using second type of the promotion. Okay. Now, you are given that there is one promotion for day 1. So basically, which actually tells us that after buying M potatoes, you get 1 potato free. Okay. So, what you can do is, you can actually divide your N by M plus 1. And then if you multiply this by M, what do you get? This is the cost of M plus 1 potatoes. Sorry, one single potato. Okay. So basically what I'm trying to say is that what you can do is first try to see how many potatoes you can buy using this M plus 1. Okay. So basically you had a N. Okay. When you divide this by M plus 1, okay, this actually tells you, let's take an example. Let's say your N was 10 and your M was 3. Now you know that if you actually buy 6 potatoes, you will get 2 potatoes free. How do you really find this? What you can do is you can divide N by M plus 1. Okay, so when you divide N, that is 10, by M plus 1, that is 4, you see that you get 2. That means you can actually buy twice times M potatoes using this scheme. Okay, and what is the price of this scheme? A. Now, how many potatoes are you left with? You will be left with N percentage M plus 1 potatoes, which you can buy either using A or B, whichever is minimum. So basically what your answer becomes is, you need to do divide N by M plus 1. Okay, this is cost of 1 potato. Multiply this with M. Okay. Now multiply this with A. Okay, this is your cost of all the potatoes that you can buy as a set using the promotion. Now you need to add N percentage M plus 1 times minimum of A comma B. This is one probable answer. The other probable answers were B times N and A times N. Okay, so try this using A times N and try this using B times N. Okay, this case you don't really need to explicitly write because this is already handled in this equation if you see. Okay, and that's it. Basically you need to find the minimum of all these answers. Whichever is the minimum, that is the answer. Okay, is this clear to everyone? I know this is a little complex. Okay, and that is why I said problem A was little harder than the usual problem is. But yeah, that is how you have to solve it. I'll quickly show my code as well, but before that, let me just know that if you are able to understand this problem or not. Okay. Maybe there is an easier formula also. Okay, I could think of this one only. If there is any easier formula, just let me know. Okay, let me quickly show the code as well. So this is the code. Okay, now if you see, okay, let me just take a screenshot of this. Now, if you see, this is not required. These two lines are not required at all. This is the same formula that we talked about. Okay, you're dividing n by m plus 1, multiplying this by m, now then multiplying this by a. Through this, you get cost of all the sets that you're about to buy. Okay, then you need to buy all the remaining ones. How do you count the remaining ones? Remaining ones will be n percentage m plus 1. And then multiply these with minimum of a comma b. Okay, so these two steps. Okay, and then there is one other probable way, that is a times n, and the other probable way is b times n. So you check with all these, find out the minimum, and then print. That's it. Okay, Ayush says m plus was not intuitive for me. Okay, you will actually start getting these intuitions once you keep practicing, once you start giving more and more contests. Okay, all right, so that's all about problem A, and I can say it was a little harder than usual problem A's. Okay, but hopefully everybody knows how to solve this now. Okay, all right. If you want to look at my summation, you can just go to my profile and then see. Okay, I'm not gonna wait. Let's move to problem B now, which is Fedya and array. All right, so this is a very interesting problem. I would say one edge case which you need to figure out, and then only you will be able to solve. A expected rating, I think 1500. Yeah. All right, so for his birthday recently, Fadya was given an array A of n integers arranged in a circle. For each pair of neighboring numbers a1, a2 till an minus 1, an and a1, the absolute difference between them is equal to 1. Okay, so basically what do you really have? What you have is, so you have a circle, this is a1, this is a2, this is a3, so on till a of n. Okay, and you're given the difference between adjacent values is 1. It is fixed, it is 1. Okay, now let's call a local maximum an element which is greater than both of its neighboring elements, and local minimum which is minimum than both of its neighboring elements. Note the elements a1 and an are neighboring elements. Okay, so basically what do you have? You have a circle, and in these circles you have some values arranged. Okay, now in this circle you can actually say that, let's say this value is your local minima, this value is local maxima. Why? Because this value, if this was local minima, then that means this was smaller than this value and this value, and if this is local maxima, then this was greater than this value and this value. Okay, now unfortunately Fedya lost an array, but he remembered in its sum of local maximas x and sum of local minimas y. So basically you had some local minimas, some local maximas. You found the sum of both of these values separately. The sum of local minimas is x and sum of local maximas is y. Now given x and y, help Fedya find a matching array of minimum length. So let's just look at the example only first. So in the very first case, if you see, what do you have? A is 3 and B is minus 2. Okay, and the answer for this is this, that you need to have a circle with 10 values. So let's write 0, 1, 2, 1, 0, minus 1, 0, minus 1, 0 and 1. Now let's mark all the local minimas and maximas. Okay, so let's mark all the local minimas first. So this 0 is a local minima because this 0 is lesser than 1 and 1 on both the sides. Okay, then what other local minimas do we have? I think this 1 is not a local minima nor a local maxima. This 2 is a local maxima. This is a local maxima. Okay, now moving forward, this 1 is nothing. This 0 is also nothing. This minus 1 is actually a local minima. Again, this 0 is nothing. This minus 1 again is a local minima. Okay, and then if you see, this 1 is a local maxima. Now what is sum of all the local maximas? 1 plus 2, which is 3, and A was 3. What is the sum of all the local minimas? 0 plus minus 1 plus of minus 1, which is minus 2, and minus 2 was the sum of local minimas. So this is the right answer. Okay, you have to figure out the minimum size of the array. Okay, otherwise you could print anything, but it is given that you need to find the minimum size of the array. Okay, that is the interesting part about this one. Okay, so I'll tell you one approach and then I'll tell you the problem with that approach. Okay, so let's just move on to a different page. Okay, so what was the problem? Let's see. So basically what we had was, we had a circle, and in the circle we had A1, A2, A3, A4, so on till A of n. Now, in order to have a local minima, what do you really want? That you're coming from some AI, then your value drops to A of I plus 1. Okay, and then so let's write A of I minus 1. You're coming from A of I minus 1, then your value drops to A of I while coming to A of I, and then in the next value, again the value increases A of I plus 1. Okay, and how do you find the local maxima? Okay, in order to find the local maxima, you have some A of I minus 1, your value increases for A of I and then again decreases for A of I plus 1. Okay, that is how your local maxima comes. Okay, now you need to figure out the minimum size of the array such that the sum of all the local maximas, their summation is A, and summation of all the for local minimas is B, and for all the local maximas it is A. Okay, now this is a completely intuitive problem. There is no particular logic for this one. Okay, you just have to keep on thinking about the random solutions that you can get, and then see if this will give you a minimum solution. Okay, so I'll tell you one solution how you can do is, let's say your A was what? Summation of all your maximas. Okay, and B was summation of all your minimas. Okay, now if you see, what you can actually do is, you can have 1, 0, 1, 0, 1, 0, so on till sum of all these values. Okay, sum of, let me see, sum of all these values becomes A. Then after this, what you can do is, so in the end you'll actually have a 0. Okay, sorry. In the end you will have a 0. Okay. Then what you can do is start with minus 1. So you have minus 1, 0, minus 1, 0, minus 1, 0, minus 1, such that sum of all these values is minus B. Okay, basically if you see, this will end with a 0. Okay, now if you see, let's take a closer look at this one. This one is a local maximum because it is greater than this 0 and this 0. Similarly, if you look at this one, this is greater than this 0 and this 0. Similarly, this one, this is greater than this 0 and this 0. So all these ones are actually local maximas. Similarly, if you look at this minus 1, this minus 1 is greater than this 0 and this 0. Similarly, this minus 1 is greater than this 0 and this 0, lesser than this 0 and this 0. So all the minus 1s are local minimas. Okay, so if you find out all the sum of all these minus 1s, you'll get minus P. Now, you could actually submit this, you could code this up and submit this. The solution size of this entire array will be twice of A plus absolute value of B. Okay, but there is one problem. Okay, or instead of writing this, let's write A minus B only. Okay, there is one problem. Okay, if you see, we have assumed that A is greater than 0. We have assumed that A is greater than 0 every time, greater than equal to 0. What if A is lesser than 0? Okay, for example, let's take one case for this one. Let's say or A was 3, B was minus 2. So our answer would have been 1, 0, 1, 0, 1, 0. A sum of 3 is done. Now start taking minus 1s. So we have minus 1, 0, minus 1 and 0. If you see, sum of all the local maximas is 1 plus 1 plus 1, that is 3. Sum of all the local minimas is minus 1 plus of minus 1, which is minus 2. So this answer is right. But what if your A was, let's say, minus 1 and B was minus 3? What do you do then? Okay, how do you find all these local maximas? Because your summation of local maximas is minus 1. Okay, so what you have to do is, now this again is an intuitive approach only. You can't, there's no particular logic for this. You just have to keep on thinking and then you'll get this approach. What you have to do is take A, then start moving towards B, and then again come back to A. What I'm trying to say is that, let's say we had minus 1, or let's take positive values only. Let's say A is 4, B is, A is 2 and B is minus 2. Okay, for simplicity's sake, let's take this example first and then we'll do for this one. Okay, what you have to do is take 2, then 1, then 0, then minus 1, then minus 2. Then again minus 1, then 0, then 1. Now if you see, there is only one local maxima and one local minima. This is the local maxima and this is the local minima. No other value is a local maxima or a local minima, because in order to have this one to be a local minima or maxima, it has to be greater than all the both the neighboring values or lesser than, but it is none of them. That's why this 2 is your A, this minus 2 is your B. So what we did was started from A and kept moving till we reach B and then again come back to A. Now let's take this example. So we had minus 1, we had to start with minus 1, move till minus 3. So we had minus 1, minus 2, minus 3, then come back to minus 1. So we have minus 2 again and then minus 1. This is your local maxima and this is your local minima. Summation of all your local maximas is minus 1, summation of all your local minima is minus 3. Okay, that is how you have to solve this problem. Okay, alright, so I hope this is clear. The only reason why this approach is working is because we knew that adjacent values have an absolute difference of 1 only. If the difference could have been greater than 1, then there would have been an entirely different approach. Okay, but since the constraint was adjacent values need to have a difference of 1 only, then only we can do this. Okay, I use the second approach. Yeah, only the second approach will work because the previous approach will give you a wrong answer. Okay. Alright, so I hope this is also clear to everyone. Let me read the chat. Namaskar, please do regular contest or Codeforces contest. Yeah, I will try. Rutul says A equals to 16, B equals to 14. We can make 8, 7, 8, 7. I could not figure out how to cover this. A is 16. Yeah, you could do that. Okay, but that only works for one condition only, when your A and B are relative. You took that, okay, 16 and 14, both are multiples of 2 with 8 and 7. Okay, for any other example, this wouldn't work. So this is a very common way through which, general way through which you can solve for all the problems. So for basically A 16 and B 14, what you could have done was start from 16, then 15, then 14, and then come back to 16. Okay, that is how you have to solve this. Let me quickly show the code as well, although there is nothing much in the code. So I'll just show my code. So sorry. So as you can see, what I'm actually doing is my current in the start is A. So I'm starting from A. Then you see, I'm just taking while my current is not equal to B, which means I'm moving till B. Then after I reach B, I again say while my current is not equal to A. Then I come back to A. That's it. Okay. I keep on printing all the values in the between and then just new line, and that's it. Alright, so in case of 3, 0 is 3 to 2 is valid. In case of 3, 0, so if you have A is 3, B is 0, you are saying 3 to 2 is valid. 3, 2 and 2. No, 3 to 2 is not valid because this 2, if you look at this in a circular way, this 2 and this 2 are neighbors and they don't have an absolute difference of 1. So this is not a valid answer. Alright, so I hope this is clear to everyone. Okay, and we can move forward to the next problem. which is what? Dora and search. Okay. If x equals to 10 to the power 9 and y 0, then won't it hit the TLE as array size will be 2 to... Yeah, it will actually hit. And again, a very good question. If you look at the problem, it is given in the output. Let me just open it. It is given, it is guaranteed that sum of n, it is guaranteed that sum of n overall test cases does not exceed 2 into 10 to the power 5. Okay. Alright, so is the contest unrated for problem F? No, it is not unrated. You can just go and check the announcements. Mike has given an announcement that it won't be unrated. And yeah, actually I was even amazed like why so many submissions on F. Wouldn't it give TLE as A, B range is in 10 to the power 9? No, they have given your inputs in such a way that your answer won't exceed, the size of the array won't exceed twice 10 to the power 5. Okay. So the case you are saying, they won't give that case. Okay. Alright. So let's move to problem C now. Okay, Dora and search. As you know, the goal Dora is always looking for something. This time she was given a permutation and she wants to find such a subsegment of it that none of its elements at its end is either the minimum or the maximum of the entire subsegment. More formally, you are asked to find the numbers L and R such that AL is not equals to minimum of AL till A of R, or like, so basically the minimum of the segment or the maximum of the segment, and similarly A of R is also not equal to the minimum and the maximum. Okay. Now, this is a general definition of permutation only. So, let's skip there. Now, help Dora find a subsegment or tell her that such a subsegment does not exist. Okay. So, the good thing about this question is that we can actually print any solution. If there are several solutions, print any of them. You don't need to find the minimum size of the array or the maximum one. You can print any solution. Okay. And that is why this question was very easy. Okay. So, basically what you're given is, you're given an array A1, A2 till let's say A of n. Okay, now you need to find such a subsegment out of this, okay, such that AL is not equal to, okay, is not equal to minimum of the entire segment or the maximum of the entire segment, and similarly AR is also not equal to minimum of the entire segment and the maximum of entire segment. Okay, Shatash Singh wouldn't give TLE as A and B ranges in 10 to the power 9. Basically, in the question, it is given that they have given the input in such a way that while finding the minimum array answer, the size will be less than twice of 10 to the power 5. So they will give the input in such a way only that it doesn't exceed the limit. Okay. Alright, so for this one, how do we find this AL and AR? Okay. Basically, let's see, like, let's look at the entire array first. Okay. Let me just open up. Okay. Yeah. Okay. So we had the entire array A1, A2, A3 till A of n. We know if you look at the entire array, its minimum is 1 and maximum is n, since it is a permutation of size n. Okay. It might be that in the entire array only, this A1 is not equal to 1 or n, and this AN is also not equal to 1 or n. Okay. But what if one of these is equal? What we can do is, we can just cut the subsegment. So basically, what I'm trying to say is that, take the entire array first. Let's put one pointer here, put one pointer here. Let's call this as left, this as right. Now check if your left is equal to 1 or n. Okay. Or if your right is equal to 1 or n. If that is the case, move your left forward. Okay. If left was equal or if right was equal, move your right backwards. So basically, when you took the entire array, now you are trying to shrink the array such that these conditions pass. Okay, now you will say, when we actually shrink the array, what if this value was the minimum value, and now then minimum will change for the different subsegments. So basically, if this was the entire segment, when you remove this value, maybe this was 1, and now the minimum of this segment changes. Yes, that is possible. So what you do is, with this you actually have a set. In this set you have all the values 1, 2, 3, 4, so on till n. Okay, now when you are taking this segment, okay, we know that in this set all the values are sorted. So when you take the segment, you have your left pointer at here and you have your right pointer at here. You will check if your left is equal to 1 or n, or if your right is equal to 1 or n. Let's say our left was equal to 1 or n, any one of these values. Okay, you will move your left forward. Along with it, what you'll do is take the value which was at the left and remove it from the set, so that in the next turn, while you are checking for this segment, while checking for this value, you will see the minimum of this set, which is the very first value in the set, and the maximum value will be the very last value in the set. So your minimum and maximum will keep on updating. Okay, so when you remove this value, the minimum or the maximum might have been updated, and now for this you will use the new minimum, which is intentional. Okay, so that's it. That's all you have to do. Take a segment, start your left pointer from the left, and start your right pointer from the right. Okay, and keep on moving. Try to shrink the array such that you come to a segment that the starting of the value and the start of the segment and the end of the segment are not equal to the minimum or the maximum values of the segment only. How you are going to check it? You will have a set in which you will only have the values of the subsegment only. Whichever value you encounter before this, you would have already removed those values from the set. Okay, so that is how you have to solve it. Pretty easy problem. I'll show the code as well. So if you look at the code, a small code only, what I've actually done is, so first in the very starting I took the entire array and made a set S in which I inserted all the values. If you see, I've inserted all the values from 1 till n. Okay, now I've taken a left pointer which is starting from 0. So if this was my entire array, this was a 0, 2, 3, so on till n minus 1. I've taken my left here and my right here. Now I'm just checking while my left is less than right, because if my left becomes equal to right, okay, then there's no way we can find an answer and we can just print -1 for that. Otherwise, we find our minimum as s dot begin, star s dot begin. S dot begin, when I do s dot becomes, it actually gives me the iterator to the very first value in the set. But I want the value, therefore I have to use a star. Similarly, I do for the maximum value, I need the last element of the set. So I do s dot r begin, which is the last element of the set, but it's a pointer to that. So use a star for that. Okay, so you have your smallest value and the largest value. Now you check if your left is equal to the minimum value or the maximum value. If that is the case, take your value which is at the left and remove it from the set, and then increment your left and then continue. While using this continue, what this continue does is, it won't take the execution forward, it will take you back to the while loop. So basically, if you have a while loop, okay, and somewhere here you write continue. Okay, so it won't take you forward, it will take you back to the while loop. This is the same case for loops as well. This is how you use continue. Okay, so if your left is safe, if your left is not equal to the minimum value or the maximum value, you go to the right, check for the right if it is equal to the minimum value or the maximum value. If it is equal, then again erase the value from the set and decrement your right. Okay, and then again continue. If both of these conditions are not true, that means your left was also a good value and right was also a good value. Then you can break out of this loop because you have found an answer. Okay, and then you can print that value. That's it. That's all you had to do. I'll just show you the code again. So this is the code. Okay, I am printing left +1 and right +1 because I have taken 0 based indexing. Okay. Alright, so that's pretty much it for problem C. I hope everybody is clear with this one as well. Again, easy problem, I would say, easier than problem A and B, I would say. Alright, so let's move to the next problem, which is D. Okay, let me read the chart. So your explanation is great. Thank you, Gaurav. Nirmal says, why can't left and right be same? they can be same. But if left and right are same, you will see that AL is equals to AR. Size of your subsegment is 1. Your minimum will be that value also and maximum will be that value also. So there's no point of checking for that case. You know your segment will be greater than 4 only, greater than equal to 4. Otherwise, you won't be able to find an answer. Okay. Let's move to Moscow and gorillas. Okay. Is my stream lagging? I don't think so, but I read a comment that it's lagging. If that's the case, do let me know. I'll just see like what I can do better in the next one. Alright. Yuvraj says, hello sir, I'm from JIT. Okay, really nice. How's JP now? I don't really have much interaction with JP people. Okay. Though I would love to go back to JP someday. Okay, let's start with Moscow gorillas. In winter, the inhabitants of the Moscow Zoo are very bored. In particular, so this is some random statement. Okay, but you decided to entertain them with and brought them a permutation P of length n to the zoo. So we have a permutation of length n. Okay, and we are calling it as P. Now this is a general definition of permutation only. So let's skip that. Okay, now after that, the gorillas have their own permutation Q of length n. They suggested that you count the number of pairs integer L and R such that max of that segment is equal to max of segment of P. Okay, so basically what you have is you have one permutation P, one permutation Q. You need to find some indexes L and R, this is L, this is R, such that your max of L to R in both the permutations is same. Okay, so that is the problem. Now, what is max? There are many people who might not know what is max. Max is a term which is generally used for permutation in which you have a segment and you need to find the minimum value that is not present in the permutation. Why it only works for a permutation? Because in permutation you only have everything once only, though it also works for multisets as well. But in a permutation, you know that you have every value for once only, and some values might be missing if it's a subsegment. So you need to find the minimum value that is not present in the subsegment. That will be the max value of that segment. Okay, so what you have to do is find how many segments are there in which the mix for that segment is same for both P and Q. I'll take the very first example. So let's take this example. Our P is what? 1, 3 and 2. Our Q is 2, 1 and 3. Okay, now let's try to find an answer for this. The very first base case is that the entire array is an answer, because if you see at the entire array, max of this entire array is 4 and the max of this entire array is also 4. So your one answer becomes 1, 3. That if you start from 1 till 3, take the entire array, max of both the values will be n plus 1. Now, what is the other answer? The other answer is if you take this value. Okay, if you take this single value as a subsegment, okay, you will see what is the max of this. Does it have, so when you're finding a max, you start with the very smallest value. Does it have that? If it has that value, then you move on to the next value and so on. Okay, does it have 1? No, it doesn't have 1. So max of this is 1. Does this segment have 1? No, it doesn't have 1. So max of this is also 1. So your another answer becomes 3, 3. And these are the only two segments through whose maxes are same for both the permutations. So the answer for this is 2. Let's move to the next case. This will actually help you find the answer. Okay. So now let's look at the question in a reverse order. How many like LNRs do you have whose max is 1? And their LNR are same for both the permutations. Now, in order to have our max as 1, we need to take a segment in which 1 is not present. Okay, if you see in the very first segment 1 is here, and in the other second segment the 1 is here. So if you take any value out of these 4 values, or any segment out of this value, their max will be 1. Okay, so if you see what you had 6, you had 3, 7, 3, 6, 2, 6, 7, 2 and 5. You could take this as a segment. The max of both these is 1 only. You could take this as a segment. Max of these is also 1. You could take this as a this as a segment. Max of this is also 1. None of the permutations have a 1. Or you could take this as a segment. Their max is 1. Or there are more permutations possible. You could take this much only. This also has a max of 1. You could take this much only. Okay, so basically this is a formula for this. Okay, if size of this is x, you will have x times x plus 1 by 2 number of pairs. Why? Because how do we do this? You can take one pair from 1 to 4, 1 to 3, 1 to 2, 1 to 1. Then you can take pairs from 2 to 4, 2 to 3, 2 to 2. Okay, then you can take your pair from what? 3 to 4, 3 to 3, and then 4 to 4. How many pairs do you have? These are 4 pairs, these are 3 pairs, these are 2 pairs, this is 1 pair. Summation of all these is 10. And if you find the answer through this formula, you will have 4 times 4 plus 1 by 2, which is again 10. Okay, so for a length of 4, you were able to find 10 such values. Okay, so if you look at this 4 and 4, again, this has a length of 1, so you'll be able to find one more summation. Okay, so you have 11 such subsegments whose max is 1 for both the permutations. Okay, so we are done for 1. Now let's move forward. I'll just erase this. Okay, now let's try to find out how many segments do we have whose max are 2. Okay, alright, so how many segments do we have whose max is 2? So if you see, our 2 is here and here. We need to take such a subsegment whose max is 2. How do we ensure its max is 2? We need to ensure that that segment has a 1. Okay, now since here we have a 2 here. Okay, let me write this array: 7, 3, 6, 2, 1, 5, 4, 6, 7, 2, 5, 3, 1 and 4. Now if you see, 1, 2 was here and 1, 2 was here, which means there is no point of taking these two values, like, okay, these two indexes. But is it possible for us to take any of these values? If we take any of these values in this segment, do they have 1? No, they don't have 1. So we cannot take this as a segment also. But what is the max of all these 3 values? Max of all these 3 values is 2, and max of all these 3 values is also 2. Okay, so if you see, but what is the smallest subarray in this whose max is 2? Smallest subarray is this. Okay, if you see, we know that we cannot, now we need to see how much can we expand our array. Okay, how much can we easily expand this array such that max remains 2 only. If you try to expand this in the left side, you will see you will get a 2. So there is no point of expanding there. Okay, but can we expand it in the right? Do we have any 2 there? No, we don't have any 2 there. So yes, we can expand it to the right and make this subarray as well. So we have 2 such combinations in this. So we add plus 2 here for 2. Now let's take the same example only. Can we find any segment whose max is 3? Okay, if you say, if you try to see, there won't be any segment because 1, 3 is here, 1, 3 is here. Okay, but 2 is here, 2 is here, 1 is here, but this one is after this 3, so you won't be able to find any segment. For 4 you will be able to find 2 segments, and then for 7 no such segments, but one entire segment also, so the answer will become 16. Okay, but how do we really find this answer? Let me show you. Okay, or instead of taking this, okay, so what did we really have? We had 2 permutations, A1, A2, A3, so on till A of n. Okay, and another permutation Q, again A1, A2, so on till A of n. Okay, our answer will be all the pairs when our max was 1 plus all the pairs when our max was 2 plus all the pairs when our max was 3, so on till our max was n plus 1. Why n plus 1? Because there is one case in which if you take the entire array, your max comes out to be n plus 1. So it is true for both the cases. Therefore, one case is that for that one as well. Okay. So we need to find all these values. Okay. And we need to find the summation of that, and that will be the entire answer. Now, how do we find this? Let's say when we had this array, okay, let me just take two arrays. Let's say this was one array, and parallelly we had another array, and we were trying to find is there any possible way that our max is equals to I? In order to have our max equal to I, we need to ensure we have all the values from 1, 2, 3, so on till I. Let's say we found that our 1 was here in the upper permutation and our 1 was here in the lower permutation. 2 was somewhere here, 3 was somewhere here, and so on. And in the end, we were able to figure out that, okay, I was here and here. Now, through this, we can say that if we take this segment, all these values have all the values from 1 to I minus 1. And they don't have, this is I minus 1. Okay. And they do not have I. Let's say our I was somewhere here, and in the right side it was somewhere here. Which means this is the minimum size. Okay. So this is the minimum size of the array that we need to take. And can we expand it on the left or right? Yes, we can expand. We can take these many elements such that I doesn't come, and we can take these many elements such that I doesn't come from the right as well. Let's take length of this is L, length of this is R. So total values for which my max is equals to I will be L times R. I'll tell you why. Let's say this was one segment. Okay, and we had one value here, one value here, one value here, one value here, one value here. Okay, and then we had I here, I here. This segment had all the values from like 1, 2, 3, so on till I minus 1. Okay, if you see, so we had already taken these segments. We can take 2 more values on the left, 3 more values on the right. So with every new value on the left, we can expand it with the right value. That's why L times R. Okay, but how do we really find the length of all these smallest segments? Okay, we need to find these in a prefix sort of a way. Basically, what I will do is, I will say that while finding my max for I, I need to ensure that it has all the values from 1, 2, 3, 4 till I minus 1. But I also know that while finding my max for I minus 1, okay, I had to ensure that find the smallest segment in which I have 1, 2, 3 till I minus 2. And if you see, this is also I minus 2. I can actually take all these values from here. This will give me a segment. Let's say that this gave me a segment whose index was, if this was my entire permutation, this was L and this was R. Okay, what is L? L is nothing but the lowermost index where you have all the values starting from 1 till I minus 2. R is the maximum index where you have all the values from 1 to I minus 2. So basically this subsegment has all the values from 1, 2, 3 till I minus 2. Now I will see, now there are some cases, my I minus 1 might be here, here or here. What I can do is, I can say my L will be nothing but minimum of L comma position of I minus 1. Similarly, my R will be nothing but maximum of R comma position of I plus 1. And I will do this for both P and Q. Okay, through this, you will be able to find out the smallest segment where you have all the values from 1 to I minus 1. Okay, so can you see how I'm pre-computing all the values and then using it for the next answer? Okay, this is not really DP. Okay, this is something you do in DP, but this, I don't think you can actually call it a DP. Okay, some of it you can say, okay, but it's a different approach only. So Now I know, okay, now after doing this, I know that if this was my entire segment, I know a segment in which I have all the values from 1 to 3 till I minus 1. Now I just need to see where is my I in the pth permutation and in my qth permutation. Let's say, okay, in my pth permutation, let's say my I was here, in the qth permutation it was here. Then I need to find out this distance and this distance, multiply these distances. Let's say this is can left and this is can right. All the places I can go in the left and all the places in the right. My answer will be can left times can right. This is only for mix of I. I need to do this for all the values. Okay, so again, I'll repeat everything what I've said. Okay, so first you need to find the base case which is for 1. How do we find mix of 1? Sorry, 1. You had this permutation P, you had this permutation Q. Okay, what you do is, let's say 1 was here, 1 was here. First you take this segment. Okay, first you take this segment, which is nothing basically. First you take this segment. Let's say there were some values in this. Okay, let's say there were x values here. So answer will be x times x plus 1 by 2 plus, you need to find all the values that you have in the middle. These are, let's say, y. So y times y plus 1 by 2 plus all the values in the right. Let's say these were z. So z times z plus 1 by 2. Okay, this is only for mix of 1. Okay, now you will start pre-computing for mix of 2. When you have mix of 2, what you will say is, let's say this point as left, the minimum index where you had 1 in either P or Q, and let's say this point as right, the minimum index where you had 1 in P or Q. So what did you have? You had this entire permutation. Okay, and you have left here and one right here. This left is for because this one is here, and this right is because this one is here, which means you have taken this segment and said that for 2 you need to take at least this segment. Now you need to find all the, like, where 2 is present in both the permutations. Okay, let's say 2 was present here and here. Now you find out the distance of this and this. Okay, when you find this distance, let's say this was x, this was y, you will say your answer plus equals to x times y. Okay, and after doing that, you will say my left is nothing but minimum of my previous left and position of 2, and my right is maximum of previous right and position of 2. So if you had this entire array, you might had your previous left here and right here. The next value, which was I, might have come up here and here. Now you will update your L with here and your right with here. Now your new segment becomes this and this. And now you need to find all the places where you have I plus 1, I plus 1. That is how you have to do it. Okay. I hope this is clear to everyone. Okay, although little trickier to understand, I'll show my code as well and then try to explain this again so that it's easier for you. Is the round unrated now? I don't think so. What is LNR? I've already told what is LNR. Okay, it is good, sir. Better placements, better atmosphere. Just had Striver here for a fest. Yeah, I heard about that. Nikhil, mix can be one or something else, so I included all the segments where L is length of segments. Okay, now when I is included one in subarrays, then I calculate prefix mix for such subarrays and add them to the answer, but it gave me, yeah, it will give you a wrong answer. Okay, so let me just again go back to the question, show my code and then try to explain like how I'm doing. Okay, so this is the code. Alright, so what am I really doing? Let me show you. The very first thing that I'm actually doing is, where is white? Okay, okay, black only. Okay, so this is my P. This is my P. And then I have my Q. The very first thing that I'm doing is, okay, while scanning, I have made two maps. P and Q. My P actually contains, like P of I will tell me where my I is present in this permutation. Q of I will tell me where my I is present in the second permutation. Okay, so first I'm saying my left and right are equal to minimum of P1 Q1 and maximum of P1 Q. Let's say my 1 was here and here. So my left becomes here and my right becomes here. Okay, now I need to find all the subsegments where my mix was 1. Okay, one subsegment could be this, where I don't have any 1. One segment would be this and one would be this. Okay, to find all the values, all the pairs I can have in this value will be what? Answer equals to left minus 1 times left by 2. Because if this is left, length of this is what? Left minus 1. So left minus 1 times left minus 1 plus 1, which is left only, by 2. Similarly, how many values can I get from here? The number of values in this will be what? N minus right. So n minus right multiplied by n minus right plus 1 by 2. Okay, and all the values in the middle, which is nothing but right minus left minus 1. Okay, so all the values in the middle. Okay, again def into def plus 1 by 2. So we have all the subsegments where our mix was equal to 1. Now we need to find all the values for 2, 3 and 4, so on. Okay, so we have our L here, R here, which means that if this is a P, this is our Q, this is 1, this is a, we have already marked this segment that, okay, we need to take this segment at least for the next round. Okay, now we say how many values, how many segments do I have where my mix will be equals to 2. Okay, in order to find that, I already know where my 1 was. So I just need to find where my 2's are. Let's say this 2 was here or here. Then this logic, in this logic, I'm just trying to figure out how much I can move in the left side and how much I can move on the right side. Let's say this as ken left and this as ken right. Okay, when you multiply these two, you will get mix of 2. Then moving forward, I'll explain this part in a bit. Okay, moving forward, what you do is you update your left. Your L was here, R was here, you update these two values. Okay, you say your left now becomes the leftmost position of 2 and right now becomes the rightmost position of 2 or your previous right, whichever was maximum. Okay, so, and that is how you keep on moving forward. But let's discuss about this part. Like, how do we find how much we can move on the left side? Okay, so basically, if you see, if this is your entire array, okay, and let's say you have already taken this segment saying that, okay, I have all the values from 1 to 3 till I minus 1 in this segment. Now there are 3 cases. Okay, it might be that your I is here, like in the first permutation as well and in the second permutation as well. One case could be your I is here in both the permutations, or one case would be your I is on the left side in one permutation and on the right side in the other permutation. For simplicity, I say that, okay, find my position of Pi and Qi, whichever is minimum, say it A and B. Okay, so if you had, let's say this segment, let me just rub some of it. Where can I really write? Okay, let's say if I had what, this, my A is leftmost position, B is rightmost position. If my B is less than left, okay, let's say this was L, this was R. I am saying if my B is less than left, that means my B is here. If my B is here, I know that my A is here on the left side only because A was lesser than B. Which means how much can I move on the left side? I can move this much on the left side. R minus B. Sorry, L minus B. Left minus B. And how much can I move on the right side? I can move till the end. So n plus 1 minus right. The other case is, what if my A is greater than right, which means my A is here. If my A is here, my B is also here. because my B is greater than A, which means I can move till the end on the left side. So my can left becomes left, and my can right becomes A minus right. And the third case is when my A is here and my B is here. In that case, I can only move this much in the left, which is left minus A, and I can move this much in the right, which is B minus right. Then I just check if both of these are not equal to 0, then I can just multiply these and get an answer for that particular MEX, add that to the answer, and then keep on moving forward. That's it. This answer plus plus is for the last condition when I have to find my mix for N. That is the entire array only. So I have answer plus plus, and that's it. Sorry, max of N plus 1. Okay. I hope this is clear to everyone. Okay, a little complex, but again, not very much difficult. Again, the rating for this was also 1750 only. Okay. Ansh says yes. Perfect. Alright, so if you are clear with this one as well, I don't think there's any more questions left for us to discuss. We had to discuss A, B, C, D only, and we are done with all the 3 problems. If all the 4 problems, if there is any doubt any of you have, just let me know now, or else I'll end the stream. Okay, and do like the stream, guys. I only see 17 likes to the stream. I am not sure, but it is said that okay, likes really helped for recommendations. All right, so Jile says liked it. Thank you. Your likes to 17 ही है अभी. Okay. Overall, I would say the contest was a good, pretty equal distribution till Dth problem. Okay. I wish F was not plagiarized, but it's okay. Like, not the problem author cannot really know like if there is any such problem or not. Jile says, "Kya?" Okay. Yeah, cap theorem. Okay. I don't see any questions in the chat till now. I'll just wait for a few more seconds, if anything. Why unrated question F? Yes. No, it's not unrated. Unrated, I think. Let me just check. Let me check if there's an announcement or something. No, there's no announcement for that. No, it's not unrated. It is rated. We have another contest tomorrow, and I think it's at a usual time only. Yeah, it's at 8 only, I think. Yeah, it's at 8 p.m. only. So we'll cover that contest as well. Hopefully. Like, even I don't know. I sometimes schedule the stream and then I have to leave it. Even the last contest that I gave, I started the contest. I like solved 2 problems and then I had to like leave the contest in the middle only because I had some work issue. So can't really be very sure about it. Anyways, is there anything in the chat? No, nothing. Alright, so I'm just ending the stream now. Let's meet tomorrow. And yeah, that's pretty much it. Do subscribe to the channel if you're not subscribed yet. And also tell your friends about this channel as well. Because I honestly, like, I don't know why, but I receive way too many messages on LinkedIn about how good these streams are. I honestly don't know why you find these streams very good. Education round sometimes comes quite hard. Yeah, I also agree with that. It's more about mathematics, I would say, sometimes. Okay, with this, I'm ending the stream. Thank you for watching, guys, and let's meet tomorrow.